Part 5. The student repeats the experiment starting with 25 centimeters cubed of 0.08 molar HCN and adding a total of 45 centimeters cubed of the sodium hydroxide. Predict one similarity and one difference between the pH curve with propanoic acid and the pH curve with HCN. Use the information from table 20.1 and your answer to part B3. So your table 20.1 is your table of Ka values, which was right at the start of this question, which you can see here. So let's look at that first of all. The Ka value for HCN, 6.17 times 10 to the minus 10, compared to propanoic acid, 1.35 times 10 to the minus 5. Your Ka value is significantly smaller. Now remember, Ka is a representation of the amount of dissociation. Okay, now this dissociation is tiny. That must mean that hydrocyanic acid is a very weak acid. It's weaker than propanoic acid. So, if I bring in my pH curve, if HCN is a weaker acid, the pH curve is going to start at a higher pH. So it could be starting around here somewhere, around pH 5, as opposed to pH 3. So that is one of your differences. So the pH curve will start higher. That's because HCN is a weaker acid. Okay, it's not asking to explain, but I've put that in there just so you can see what's going on there. So, if it's a weaker acid, if it's starting at a higher pH, another difference you could add in there, or you could add instead of this, is that the vertical section is shorter because it's starting at a higher pH. The similarity then, we're using the same volume and the same concentration of the sodium hydroxide. So the similarity is the pH curve will level off. It will end in the same place because we're ending with an excess of sodium hydroxide at the same pH as it was before. So the similarity is the pH curve ends in the same place. There's your 2 marks there. So other answers you could have, the endpoint or the volume of sodium hydroxide need to neutralise the HCN is the same, it's going to be 20 centimeters cubed, or the pH, the final shape of the curve after the endpoint is the same, or like I said, the pH curve ends in the same place. Part C. The student calculates the pH of 0.08 mole per decimeter cubed HiO3. The student assumes that equilibrium concentration of HiO3 is the same as the initial concentration. The student measures the pH and finds that the measured pH value is different from the calculated pH value. Explain why the measured pH value is different from the calculated pH. So for this one, we again go back to our table of Ka values. Now we can see right at the top there that HiO3 iodic acid has a Ka value of 1.78 times 10 to the minus 1. So whilst it's not a strong acid, because we've got a Ka value, it's not fully dissociated, it's certainly stronger than the other two. So because it's bordering on a very, very full dissociation, it's very difficult to make the same assumption that we make for all the other weak acids. Okay, we always assume that dissociation of a weak acid is minimal. So therefore the concentration of your undissociated acid and the concentration of hydrogen ions are equal. But it is an assumption. The stronger the weak acid is, the more dissociation is taking place, and that assumption starts to actually fall apart and not make, we can't, and therefore be less accurate. So there's a couple of answers, ways of wording your answer for this question. And I'd simply say that the iodic acid dissociation is not negligible, okay, or say it is dissociating to a larger amount. You could even say that to refer to the Ka, the large Ka value indicates that HiO3 is a stronger weak acid. All right, so the assumption that we're making is not the case because HiO3 is dissociating more than other weak acids. So the concentration of HiO3 is therefore not equal to the concentration of H+, which is the assumption we make for any weak acid.